you know, n to the n plus 1 over n plus 1, you need to do that in your head. But these, you need to put to memory like on an index card, and you need to memorize it before you take the test.
So what's the C?
The C is always going to be there because you're doing a whole family. Remember me talking about that the other day? What's the derivative of x squared? What's the derivative of x squared plus 5? What's the derivative of x squared plus 107? So what's the antiderivative of 2x? X squared, 2x. Antiderivative of 2x is x squared plus what? C.
Yeah.
Why?
It could be any number.
There you go. That old light turned on, didn't it? It could be any number. So you have to put that C there. And some, you know, the dx, putting the dx in there, some teachers will have a cardio, what is it? Cardio infarction? Cardio infarction if you don't put the C. They'll go crazy. They'll just, they'll mark it wrong and they'll put X's all over it, and you know how they do. Okay, so you need to make sure you put the C there. And sometimes, see, that's the thing about web science. Sometimes they'll put, and you'll notice this in the integral homework whenever we do it, they'll have a box, and then they'll have a plus C, and then the next problem will be just a box, and if you don't put the C, you get it wrong. Some of them they put the C with it, some of them they don't. That shows you the difference between an educator and an engineer. An educator would leave the C off of every single one of them if they wanted to drive that point home. So why would you put, I don't know, maybe I guess you could pick and choose. I don't know. Who knows? When you're a GOD god, you don't get questioned. GOD, lowercase GOD. I'm going to wait on the integration on trigonometrics. I'm going to make that a separate section, if you don't mind. Okay, we've already went over this. I thought we were in indefinite. I guess not. Okay, we'll go ahead and start. I really don't want to do that. I don't want to do that yet. Okay, rate of change, you need to write that down. When you're trying to find the rate of change, which is the slope, you can also use antiderivative or the antiderivative of the derivative. Basically, the antiderivative of the derivative of the derivative of the function is equal to, and plug it in, and that's what, you know, that's the antiderivative of the derivative. And an example would be, they don't give you an example yet, but here's an example. The antiderivative of v of t, but that's not a good one. Here's one. The particle moves along a line, so this velocity at time is v of t is equal to t squared minus t minus 6. Find the displacement of the particle during, well, you've got your 1 to 4 here, so it's going from 4 to 1, or your distance is from 4 to 1, so that means your b is going to be 4, your a is going to be 1. Don't turn it around and do 1 to 4, because then you'll get a negative, and then you'll look at it, stare at it for an hour. All right? And then just take the antiderivative of t squared minus t minus 6. And that's what you get. So I'm not going to spend a lot of time on that. We'll get to the advanced stuff. That's when we need to spend a lot of time on. Well, the basics and then the advanced. Substitution, the second most important, besides the basic law of. Okay? The substitution rule. Write this down. And as soon as I find it, there it is. Now, if you look at it, you ain't going to have a clue. The substitution rule, if u is equal to g of x, is a differentiable function, differentiable, whatever, how you say it, function whose range is an I, interval I, and f is continuous on I, then f of g of x times g prime of x dx is equal to f of u du. Where they get this stuff, I have no idea. They give you a crazy example to start with. Let me do another one. That's not a good example to start with.
Because they think we have our degrees already.
Exactly. Okay, we can do this one. We can do this one. This one's real simple. The antiderivative is square root of 2x plus 1. The antiderivative of the square root of 2x plus 1. The antiderivative of the square root of 2x plus 1. Is that what it was?
Yeah.
Dx. Okay, now what's the problem here? What's different here than the ones we were doing before? Well, there's radical, and there's no numbers. This is an indefinite. That's not what I'm looking for. But what is the difference between this function and the function that we did in the previous problems, in the previous examples? Huh? They're both under the radical. Well, you can't distribute. You can't do anything across the radical. So if we wrote it as 2x plus 1 raised to the 1/2 power dx, that would show you right here we ain't never took the antiderivative of something like this before. All right. So what you should do is do you remember back in algebra? I'm going to go back in time a little bit. You remember seeing something like this? X to the 4th plus 2x squared plus whatever. I can't think of one right now, but anyway, I'll just put a blank here. And you remember saying that, well, wait a minute, we can make u equal to x squared. And if u is equal to x squared, we can rewrite this as u squared plus 2u plus blank. Y'all remember doing something like that in algebra?
Never.
Okay, well then, y'all are losers and your teacher sucks. Okay? Now my students, if I had any students in here, you should say, yeah, I remember that. But anyway, you basically use substitution. And you used u. And the reason you used u was because they're getting you ready for calculus and using u here. Okay? So the first thing you do is you say u is equal to whatever the most complicated part of the problem is. And the most complicated part of the problem in this problem is the 2x plus 1 because it's inside the what? It's inside the radical, so it's not good. So you make u equals 2x plus 1. Now, I can rewrite this, now that I've written this, I can rewrite this as the antiderivative of u to the 1/2 power du. Now, it's easy to take the derivative of this, but what is du? Well, du, take the derivative of this guy. Well, u is equal to 2x plus 1. What's du? 2 what? 2 dx. You got to remember that dx because that dx is right there. So you got to put, you got u, and then you got du right here. So antiderivative of u to the 1/2, and then you've got the 2 dx du. You got that right there. So you start to think about, I can take the derivative of this, the antiderivative of this. That'd be u to the what? 3/2 over 3/2, right? But I got to have du. Well, what do I not have right here? See, I've got the dx, but what do I not have? The what? I don't have the 2. In order to take the derivative here, I've got to have u what? U du. I don't have u du. Okay? Du is 2 dx. Let me show you. And this can be confusing, and I really don't like the problem they picked for an example, but let me show you what I'm talking about. Here it is. Let u equal 2x plus 1. Then du is equal to 2 dx. So dx is equal to 1/2 du. So solve that. Solve that for dx, because you need dx right here. Now, they're showing it solving for dx. What I like to do is I like to say, hold on a second. I'm just going to pull this over if y'all don't mind. I'm just going to make it big to go along with this one. So what I could do is I could go out to the side and say u, this is the way I do it. U is equal to 2x plus 1. And then I say du is equal to 2x dx. And then I say, okay, I need a 2 right here. And then I have a what out here? A 1/2. Why? Why do I put a 1/2 out here when I put a 2 there?
Cancel it.
What's 1/2 times 2?
1.
1. So I'm not changing it mathematically. So now I have, when I do this, I have 1/2. Let me erase this because I don't like the way they do it. Okay, there's something that just popped up. I guess we're going to go through the music thing again. So I've got now I've got 1/2 the antiderivative. I'm trying to ignore it, but it's just not working. Antiderivative how am I supposed to deal with this, y'all? No, I don't want to do that. I just want to get rid of the Windows Media Player. I still think Mr. Brooks is doing that.
Do it just to have a little bit of fun.
Yeah, I figured you'd do it with your watch. All right. So 1/2 antiderivative of the square root of 2x plus 1, 2 dx. Now, when I do that, what do I have? Basically, I have 1/2 the antiderivative of the square root of u du. Tell me if I don't have that. Do I have that?
I thought thought it was 2 du. Oh no, du is 2 dx.
Mhm.
Okay, never mind.
Yeah, ain't that what I got? All right, now look at your rule for, if they have it written correctly, which I don't think they do, I mean, before you can understand it. If you have u du, then you can take the what? You can take the antiderivative. That's basically, let me see if they don't have it. But that's what they're telling you. It might be in that function right here. U du, yeah. U du, then you can take the antiderivative. I'm not going to spend time on that. Where's my problem? Must be on the next page. There it is. So now I can take the derivative of that, the antiderivative of it, which is what? U to the what? U to the 3/2 over what? Over 3/2, which is equal to 2/3 u to the 3/2. But what's out front? What's out front right here? 1/2. And the 2's cancel. And you're left with 1/3 u to the 3/2 power. Okay, hold on. Hold on. Let me erase this so I can write it. Because the first question you're going to ask is what happened to the 2? Well, the 2 was used to what? Make it look like u du. Okay? The 1/2 stays out here. The 2 got used up right here. The 1/2 stays out here.
So that's where the 1/2 came from.
So, you got 1/3 1/3 u to the 3/2 power. And what is u?
Square root of it.
Well, in this case, it's not the square root, it's what?
2x.
U is 2x plus 1
Oh, yeah.
to the 3/2. And now what is that? That's exponent over what?
And,
Well, that's going to be 1/3 times the square root of 2x plus 1 to the 3rd, which you can take the square root of that. I don't know if they want you to go this far. 1/3, and that's going to be like 2x plus 1, parentheses, times the square root of 2x plus 1. So I don't know if they want all that, but somebody look, tell me what they did in the problem. Anybody got their book open? Let's look and see what they did. One-third, 2x plus 1 to the 3/2. So they just stopped there. So they stopped right here. Let's see. This is not the best problem to use as an example. I would not use this one. That's what I was trying to find. I was trying to find one a little bit better to use. Because usually the radical messes people up. Class ends at 10 o'clock, right?
9:40.
No. Oh, next door. Oh. I was beginning to wonder. All right, here's another one. Why do they got to use these? I don't like using these. I don't want to use these. Let me find one that's Well, it's kind of hard to find one when they start off with the most complicated ones. Let me go to the homework. Okay, well, I don't do much better. Okay, let's do number 3 and number 5. Number 3 and number 5, I'll blow it up. Write down number 3 and number 5. I love when Donald Trump said last night, they asked him, they said, "You carry a gun?" And he said, "Yeah, I have a, what do you call it? Concealed gun permit, whatever." He said, "Yeah, I have one." He said, "Well, what do you think about gun-free zones?" He says, "I think they're a joke." He said, "I think they're targets for sickos." And he's right.
Is that really what it said?
Yeah.
Okay, I'll vote for him. Seems reasonable enough for me.
I mean, you think about it. If you want to go kill somebody, are you going to go to a police station or are you going to go to a school?
Maybe we should make a sign there.
Yeah, maybe that's
It's
it.
like the banks are like gun-free zones too. Like, it doesn't make any sense.
I'm telling you, the United States has turned into a bunch of pussies.
It's like telling somebody, you're like putting, "Don't rob this store." Outside your,
Exactly.
outside your front windows.
Well, both of our security guards carry. Dang old that Dodge out there carries too.
I was gonna say, what's the point of having a security guard if they ain't got a gun? What are they gonna do, hit you with a club?
Now they're going to tell you to settle down. Yeah, I just posted that where he said, gun-free zones are targets for sickos. And somebody will say, he shouldn't use the word sick. I'm sorry. If you go kill a bunch of kids, guess what you are?
Scientific.
You sick. Bunch of pansies. There's some people in the United States that I guess we just need to be chasing butterflies and throwing daisies up in the air and just running across the field.
You can't say that.
Huh?
You can't say that, that's offensive.
Oh, I'm sorry. Maybe we just need to put tinfoil on our head.
Don't make me call it PC police.
Huh?
Don't make me call it PC police.
Yeah, exactly. What's got us in this mess? PC police. All right, which one is the most complicated? Well, they tell you x cubed plus 1. So let's just write u is equal to x cubed plus 1. Then du is equal to what? 3x squared what? dx. Now this right here helps you. Write that dx down because you've got a dx in the formula. But you don't have what? Well, rewrite it. This is something I tell all my students whenever they're doing substitution. Rewrite this as square root of x cubed plus 1 x squared dx. What do you not have? You don't have what?
Oh, no, you do. I don't know. That. You have the 3.
3. Yay! And if you put a 3 in there, what are you going to put out front? Now the 1/3 is going to stay because the 3 gets used up when you do the u du. So now, what do we have? We have the square root of u, what? Du. So this is square root of u, and this is what? Du. So we have the antiderivative of u du, which means use power rule u. So 1/3 of u to the 1/2, and 1/2 plus 1 is 3/2, so that's 3/2 over 3/2 plus c. And we've got to take that 3/2 and multiply by 2 what? Multiply 1/3 by 2 what? 2/3. And that's going to leave us with 2/9 u to the 3/2 plus c. And what's u? Well, it's not square root. U is what? X cubed plus 1.
You lost me.
Hold on a second. Let me fix something. This thing doesn't write dashed lines very well. Okay, now where did I lose you?
After that, what you just did.
All right. In order to take the derivative of something, okay, let me go back. Let me do something here. All right. F of x is equal to x squared w to the 4th power. I want you to tell me how to find the derivative of this. What are we going to use? Product rule. No problem. First times the derivative of the second, which is what? 4w to the what? 3rd? Plus the second times the derivative of the first. Everybody with me? Okay. Let's go back. Let's go back. We are doing the antiderivative of two things. Do y'all see what's going on up here?
Like I said, it's going to freeze right before we
I can't get up here to. There. Sorry. What's this right here? How do you take the antiderivative of the product of two terms? You don't have a product rule. You don't have a product rule for integration. There is none. So you have to do substitution. Okay, everybody get that? There is no product rule for integration. So you have to use substitution. And substitution basically says that you can take the derivative, the antiderivative of u du. But in order to do the derivative of u du, you have to have it set up as u du. Okay? Right here. If u is equal to 3x cubed plus 1, you always pick the most complicated part. Then what is du? Du is equal to 3x squared dx. Well, we don't have 3x squared dx. We have what? X dx.
I get that. I just
Okay.
feel what you did after.
Okay, well, once we have this, what do we have? We have the square root of u, what? Du. And once you have u du, you can take the antiderivative of it by just raising this to the, take that off. Did y'all see how nice that worked? Change it to, okay. I had to say something, didn't I? To the what? 1/2 power. So what do we have? We have the antiderivative of u, what? Du. Once you have u du, then you can just use the integration power rule, which is 1 plus 2/2 over 1/2 plus 2/2. Once you have u du, then you can take the antiderivative. Does everybody see that? Okay, so let's do this one over here. Really? Did it just do that? Now the good thing about these is they're giving you u. Some of the problems that I'm going to give you for homework is not going to have u.